MSM3, Unit 3, Lesson 7, solving equations with the distributive property in like terms. So what we're doing today is we are requiring things, whether it's a distributive property or combining like terms, to be used before we start solving a one or a two-step equation. So first I'm going to look at the side with the variable like I've always done when I'm solving an equation. And on that side, I'm going to say, is it ready to be solved? What can I do? So in this case, the side with the variable has a plus 5 and a plus 10 that can be combined to get plus 15 so that I have one term with a variable and one term without a variable. Now I have a two-step equation. I would subtract the 15 from both sides. I would get 3m equals 30. Inverse operation, divide by 3, m equals 10, and I would be done. But before I could start doing that two-step equation, I had to simplify first. In this case, it was actually combining like terms because the plus 5 and the plus 10 both have no variable. In the second one that's there, I have 6x minus x plus 3, all on the side with the variables. I can combine the 6x minus x because they're like terms. I would get 5x plus 3 equals 18, and now I have a two-step equation. Adding and subtracting comes first, so I would subtract 3 from both sides. 5x equals 15. Divide both sides by 5 using the fraction bar, and x equals 3. So not too terrible yet. On the next one, when I look at the side with the variable, I have x and x. Now they're both plus, so this is like plus 1x, meaning that on the right side I would have 5 plus 2x. It's a two-step equation now. On the side with the variable, so still the right side, I have a 5 getting added to the 2x. So the inverse of that would be to take away 5. Positive 5 take away 5 would be 0. I would have 16 equals 2x. I would divide both sides by 2 and get 8 equals x. Remember, we always like to have our variable on the left. So we would rewrite it before we say, okay, this is my final answer. In the next one, you'll notice the side with the variable has parentheses, and we're going to have to use the distributive property over addition. So 4 times the x and 4 times the 6. 4x plus 24 equals negative 8. Now it looks like that two-step equation that we're used to. So I would subtract 24 from both sides. I would get 4x equals, now these are both negative, a negative 8, and I'm taking away 24. So that's going to go to negative 32. Divide both sides by 4, and we get x equals negative 8. Now, one thing we haven't talked about before is that you can use that 4 that's out here. This is 4 times everything in parentheses. You could start this by dividing both sides by 4, but it actually makes a little bit more work. So distributing it first, I think personally, is going to be the better option. So here, I have a lot going on this left side. I'm first going to simplify the distributive property, the 3 times the 4 and the 3 times minus a. So 12 minus 3a minus 5a equals 52. So if you're looking at minus 3a minus 5a, that's going to be minus 8a, right? I subtract 3a and subtract 5a. I could subtract 8a all at once. Now it looks like a two-step equation. The 12 is positive. So I'm going to subtract 12 from both sides. Negative, don't forget the subtraction that was there is worth a negative or is the same as being negative 8a equals 40. Divide both sides by negative 8, right? A negative divided by a negative is positive. A equals negative 5. Not terrible, it is doable. Still, the left side has the variables, and I can see the parentheses there again where I'm going to have to distribute. 5r, where there's nothing I can do with it yet until I've distributed, plus 7 times 1 is 7. And then I've got 7 times minus r. So that's going to be minus 7r, or you could do plus a negative 7r. They work the same. But I'm going to combine that 5r with the minus 7r. And I'm going to have negative 2r plus 7 equals 5. So if we just take an extra second, this 5r is positive, and we were taking away 7r. So if I have 5 and I take away 7, that brings me down to negative 2. Now I've got a two-step equation. Subtract 7 from both sides and divide both sides by negative 2. R equals 1. Reason for that, negative divided by negative is a positive. All right, so sometimes it may be easier to solve using reciprocals instead of the distributive property. And here's where I was going with this. Instead of distributing that fraction, which is like going to take a little bit. I might multiply both of them by the reciprocal of the 1/4. So I might say times 4 over 1 times 4 over 1. So the 4 times 24 is going to be 96. And then I only, right, because the 1 over 4 and the 4 over 1 cancel, have the x minus 8 left. Now I can add 8 to both sides and be done relatively quickly, remembering to rewrite it with the x on the left. If I had used the distributive property, which you're welcome to do, but maybe not my preferred on this one, 24 equals, if I distribute the 1/4, I get 1/4 x minus 2. Notice I'm going to have to continue operating with fractions. Add 2 on the right, add 2 on the left. And now I've still got to use a reciprocal anyway. 1/4 x, I'm going to multiply this side by 4 over 1 and multiply this side by 4 over 1. And I will get 104 equals x. I obviously end up with the same answer because everything I did was mathematically legal, but maybe had a little bit of an easier time getting rid of the fraction in the first step rather than getting rid of the fraction in the third step. We'll do one more kind of like that down at the bottom. I can, in this case, get rid of the 5 that's out in front first. This is 5 times blah, 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 blah. Okay, I don't actually care what's in there. I just know that it's being multiplied by 5. So I can divide the left side by 5 and divide the right side by 5. On the left, 5 divided by 5 cancels, and you only have the 2n plus 3 remaining, equals, and the 65 divided by 5 is 13. Now it looks like a pretty standard two-step equation. I would subtract 3 on both sides, 2n equals 10, and divide both sides by 2 and get n equals 5. Now, this is why I said it's not always more efficient. I can do the distributive property. I can do 5 multiplied by the 2n and 5 times the 3. I still have a two-step equation after my first thing that I've done. I can subtract 15 from both sides. 10n equals 50. I can divide both sides by 10 and get n equals 5. Not a significant savings, not a significant difference in how long it took or how much I had to write. So that one really comes down to preference. I think most people, though, will agree that getting rid of the fraction, if you were going to distribute a fraction, that getting rid of it in the first step using its reciprocal is probably beneficial to carrying that fraction around for a while. So you do have some options. Please let me know if you have questions.